And I'm very pleased that we have here today two people that I've known for a long time, Mr. Jim Lozier and Mr. Bob Bergman, both of whom now work for the consulting firm of CH2M Hill, but have had a long and varied career in the application of membrane technology. Now this was the pilot testing you were doing there on the reverse osmosis itself. Was that a full scale? Did you actually test the 12-inch fluid systems modules?
Yeah, there were what they call proof test units there, which utilized 12-inch and 8.5-inch elements. Bob can comment more.
Well, when I was there, they were testing all different kinds of elements, the envirogenics, one with all the membranes.
The Gatling gun.
The Gatling gun
Yeah,
style.
right.
And everything else. Ionics had electrodialysis out there, and we were, Dow had their hollow fiber low pressure, and DuPont was there, and hydronautics and fluid systems.
Yeah. We were still learning about materials for seawater plants.
The rope users,
Yes. Yes.
the rope users were 316,
Yeah.
and of course they used 6-inch pressure vessels, which are the same ones that had a Jetta. They were the studded. And I kept looking at these studded vessels and saying, I can just picture the guys out in the field looking at, this relatively large nut where it says put only like a few foot-pounds of torque on it, just cranking down on this thing and just pulling the stud right. And I mean, there was many things about the rope they use shimp. If you ever try to bat shimp up in cold seawater,
Yeah.
it doesn't do quite well. They use cationic polymer as the coagulant. Well, of course, a little bit is good, a lot's better. I mean, there was just a whole slew of things that could go wrong. But, and this is maybe you appreciate the military, you're trying to put together an RO system, drop it from a plane, have it work out in the field with limited logistics and say, it's really not, the RO system isn't the issue, it's the context of what you're trying to do that's really the challenge.
That's right.
And you have
That's
to make
right.
compromises.
In Gainesville, you started, one of the earliest projects in Florida, which was engineered by one of the predecessor companies of CH2M, well, not predecessor, but one of the companies that CH2M Hill purchased, which is Blackcurrant Eisness,
Yes.
is Cape Coral.
Yes.
And did you get to work on that at all?
No.
No?
Cape Coral was before my time, and when I started, Inglewood Water District was just built and had been running for about a year, and there were some interesting things that were happening in operations there that I got involved in at Inglewood.
Remember.
So that was the first time.
Yeah, because I was working for Hydronautics then.
Yeah.
So,
Well, the Inglewood plant was interesting in that the groundwater it's a brackish groundwater. It was very clear, low organics, but somehow it was causing a lot of flux decline on the membranes. And the feed pressures were rising up fast. In probably over a year or so, we were at the maximum pump capacity. And that's about the day that I got hired to come in. So I worked on that for a year or so, a couple of years actually. And we did some interesting test programs that you might remember at that time. We had for the plant expansion, they didn't want to just do the plant expansion without trying to figure out how to get around this fouling issue. And so we did what we called a membrane characterization program, and all the membrane manufacturers at that time, the major ones, they all pilot tested at Inglewood on this clear groundwater, had low SDI, low turbidity, but it was brackish. And I noticed that, and they tested they're all in parallel, and the flux decline that they had was all essentially proportionate to their flux rate. And I remember when testing was done, the manufacturers got their elements and they autopsied, cut them open. They're saying, man, these membranes look brand new, but we had all this flux decline. We can't figure out what's going on. It's interesting because the Inglewood is a utility. They're just looking for a way to solve the problem. They don't have money to do research. And so what they did is worked out design criteria for each membrane type for bidding for the expansion. based on the flux decline that they had during the pilot testing. So basically, operating at lower flux solved their flux decline problem, but we thought it might be some type of organic fouling, but they have low organics, so it never was money to research it. But from Inglewood testing, which was about 1986, maybe this test was going on, maybe 1985, the manufacturers all started their criteria saying for groundwater, you could have a maximum flux of this in their guidelines. All the manufacturers started to develop their guidelines on flux depending on water quality coming in, source water. And I think that Inglewood had a lot to do with that because that was an eye-opener for a lot of companies.
I actually still have a copy of your report and a photograph of the plant. Everything's painted dark blue.
Yes.
Looked like something that Darth Vader would have invented.
Well, that was another interesting thing about Inglewood is that separate from this thing, they had a microbial fouling problem because at that time, a lot of the pressure vessels weren't, they allowed light to go through. They're transparent. And so, it turned out that Paul Laverty, working for Hydronautics at that time, and we set up a test program that's kind of complicated to describe here now, but we looked at looking at opaque and translucent tubing. We used SDI pads for the measurement of fouling. We used different types of scale inhibitors, and came out that the water has no oxygen in it. It's got hydrogen sulfide, like a lot of Florida groundwaters has. But anyway, it was a sulfate reducing bacteria that was doing it, and so they ended up painting everything. There were the light coming in from the windows. Actually, the lights in the building had the fluorescent lights put out a wavelength that was great for growth of these bacteria. And so, now all the pressure vessels are opaque. But at that time it was painted. That's why they're all blue.
I ran into you on the Twin Oaks Valley project, which CH2M Hill was successful in obtaining. And I regarded that as an interesting exercise for me, because the proposals we received were so entirely different. I had assumed, in my ignorance, that all of the proposers would propose membranes, and that was not the case, which really surprised me. But you guys did, and you proposed xenon. And could you, without giving anything away, could you perhaps tell us how you arrived at the xenon approach rather than another manufacturer?
Well, of course, at that time, I think most people were of the opinion that submerged membranes for large capacity plants were the least expensive way to go versus pressurized. There hadn't been that many big pressurized plants built. And so by going to a submerged plant, you can reduce down the ancillary equipment. So you could make bigger trains, essentially reduce the number of pumps. We had already gone through and essentially designed the Lakeview plant in Ontario, which was almost 100 MGD, was 95 MGD. So we had experience with that, with a plant of similar capacity. And then, so we said, well, we're going to use membranes, 100 MGD plant. Really, there's two submerged suppliers out there in the business. It's GE, or Cenon at the time, before GE bought them, and US Filter with Memcor. So we actually got into parallel discussions during the proposal phase with both suppliers. And, it was, I won't say touch and go, but it was close. And, the day we just decided to go with Xenon. Basically, it came down to cost and what kind of service agreements we could put in place, because essentially we had the contract to operate the plant, but we knew that the membranes were really the key part of making the plant work, so we had to put in place a very good service agreement that would allow us to make sure that we had Xenon on the hook to make sure the membranes were going to work. So,
where do you think we're going in the next 10 or 20 years?
Well, I think you're right. I think the RO market is fairly well established. as you say, brackish. There's not really a lot to do, maybe tweaking around the edges in terms of energy recovery and kind of getting that refined to the point where it's maximized. I think seawater, the RO side of it, is almost there as well, although we know we have opportunities for products that can bring down the energy consumption of the membrane and still maintain the TDS rejection needed. And nano H2O being the example of somebody who's commercialized something that has the potential to bring the keys with the development of membranes. I think really the key is, will membranes remain, reverse osmosis, will membranes remain the technology of the future in terms of desalting? Will we have aquaporins or something else, which are membranes in a sense, but they're a kind of a step forward in a very different way. So I think we basically reached kind of, and I hate to say this, we've gotten close to the end of the road with a typical polyamide membrane. We need a new product, and I think we'll see that. I think Eric Cook wrote a very nice review on nanomaterials and membranes, and there's some interesting things going on in the industry that I think may take a while to get to fruition, but I think given the number of things that are happening, I think something will happen that will continue to bring down the cost, so to speak, in the energy. But that's on the high pressure side. I think obviously we have other ways of approaching the issue with forward osmosis and MD, and I think membrane distillation to me is very interesting because it has the opportunity to deal with poor water quality and higher salinity water quality, where we can get away from the osmotic pressure limitations of RO, but we have to have something obviously that can achieve sufficient recoveries to make it worthwhile, so we don't have a lot of MD membrane capacity, just like you would on a distillation plant. So I think that the MD has an opportunity, particularly if we can capture and combine it with something like solar decel. I mean solar energy. I think that combination from a sustainability standpoint, I'm kind of excited about.
Bob, what do you see in the future?
Well, I think Jim said it pretty well, but I think that sustainability is it's kind of a word, but it's really there. I mean, so many plants really aren't sustainable from a cost standpoint or from an environmental standpoint. So sustainability, using renewable energy, concentrate disposal, there's more and more talk, and there's more and more plants looking at ZLD, zero liquid discharge, but they're extremely expensive. So maybe using other technologies that, evaporative technologies, a lot of those plants use concentrate minimization with chemical clarification, but there's a lot of technologies that are out there and a lot that are popping up over the last few years to help that situation. But I think that more environmental, sustainable is going to be is where the future needs to be, really. And on the other side, I think that there's so many people in the world that don't have access to good, clean, fresh water. And if you look at the amount of people in the world that don't have access to fresh, potable water, finding technologies that are inexpensive that you can put out and will have a big impact in the world. And I think that membranes are a big part of it, using solar or other types of energy. But I think that we have a tendency to think of big plants and municipal plants and industrial plants, but with so many people in the world, billions actually, that are without fresh, clean, potable water, there needs to be an effort there as well.